Good morning, student. I am Nanda Kumar, your physics sir. Today we study about the 12th standard physics. First lesson is electrostatics. Okay. Today overview of this video content is what is electrostatics, electric charge, electric dipole, electric force or Coulomb force, electric field, electric potential, and electrical potential energy. First of all, what is electrostatics? Electro and statics. That means two words split out electro and statics. Electro means electric charges. Statics means charges at rest. The main objective of this first lesson is study about the charges, the behavior of the charges at rest position. What is electric charges? The universe is made up of fundamental particles of atoms. The atom is made up of elementary particles like electron, proton, and neutron. We already know that. Okay, what is the charge value of the elementary particle? Like electron have negative charge value, proton have positive charge value, neutron have no charge, that is electrically neutral. Objective of the first lesson is first one, how will be the charges behave at rest, how the charges are interact, the physical phenomena of electric charges. This is nothing but the electric field, electric force, electric potential, and electric potential energy. Another important thing is electric dipole. Electric dipole is two equal and opposite charges separated by a small distance is called electric dipole. Okay, we have some physical example correlated to magnetism theory. We have magnet. Magnet have north and south poles. We have two magnets. The two magnets come together. For example, one magnet end have north pole, another magnet end is south pole. The two magnets are attract together, and one magnet have north pole, another magnet have north pole. Coming together, the two magnet always repels. That means like charges always repulsive, unlike charges always attracted. The same magnetism theory is applicable to the electric dipole. Plus q charges, plus 2 charges are always repulsive. Plus charges and minus charges always attracted. That plus q charges and minus q charges separate by small distance. We know that one has one doubt. Plus q and minus q always attracted. How do we separate the charges? It is very possible the separation of the charges by using some external forces. The electric dipole is a very useful and many application in electrical devices. And another topic is electric dipole moment. Electric dipole moment, the moving of electric dipole is called electric dipole moment. In the figure 1.16, we have see that electric fields and electric dipoles. Another important topic is Coulomb force. The scientist Coulomb's law is very important 2-mark question. Coulomb's law states that the force of attraction or force of repulsion between two electric charges. The Coulombs take an idea from Newton's gravitational law. We already study that Newton's gravitational law in 11th standard, 6th chapter gravitational lesson. The Newton says that the gravitational force of two mass object is directly proportional to the product of the masses and square of the distance. Coulomb take it the same concept applicable to the electric charges. The electric charges force of attraction or repulsion is magnitude of charges multiplied together and the square of the distance between the point charges. The figure we can see that plus q and plus q charges, so we clear that idea. The force of repulsion occurs in these two charges. Another topic is electric field. According to Faraday, every charge in the universe creates an electric field in the surrounding space, and if another charge is brought into this field, it will interact with the electric field. At that point, will experience a force. Very simply say that the electric force experienced by a point charges is called electric field. We can see that figure 1.12, the plus q charge and minus q charges separate by small distance. That means that electric dipole. The electric field lines come from plus charge plus q and end from minus q. This is very similar to that magnetism. Magnetic field lines also come from north pole to south pole. It's also similar that magnetic field and magnetism theory. And some more about electric field. The plus q charges create electric field outside. Please you can see that image, figure 1.11. Plus q charges and electric field lines does not intersect. This is same properties of magnetic field lines. Thank you, students. This video is over. Any doubt or any queries, please comment in the comment section. And we do not we two topic is not complete in this video. One is electric potential and electric potential energy. The two topics is make it another video. Thank you, students.